Imagine hovering above the ground, moving faster than a cheetah, without any wheels touching the earth. Sounds like magic, right? But this is not magic, it's science. This floating wonder is how maglev trains, or magnetic levitation trains, work. Let's take a closer look at the wonders of maglev technology. Maglev trains use magnetic forces to float above the tracks, allowing them to travel smoothly and swiftly. You see, this type of train doesn't need wheels like traditional trains. Instead, it relies on magnets to lift and propel it forward. But how does it all work? Let's explore. At the heart of maglev technology are two basic principles: magnetic levitation and electromagnetic propulsion. Let's start with magnetic levitation. Magnets have fascinating properties. They can attract or repel each other. Maglev trains utilize the repulsive force of magnets to lift the train off the ground. Imagine trying to push two magnets together with the same poles. They repel each other, right? The track and train both have magnets with the same polarity, creating an invisible magnetic cushion that lifts the train, reducing friction dramatically. Now, how does the train move forward? This is where electromagnetic propulsion comes in. The track consists of metal coils that act like electromagnets. When electricity flows through these coils, they create magnetic fields that interact with the magnets on the train. By changing the polarity of these coils successively, they pull and push the train along the track. It's like using dozens of invisible hands to gently push the train forward or pull it back, allowing incredibly high speeds and smooth rides. The origin of maglev technology can be traced back to the early 20th century. However, it took many decades for scientists and engineers to develop working models. A significant development occurred in the 1960s and 1970s, when researchers in Japan and Germany made substantial strides in making maglev trains a reality. One of the most famous maglev trains is the Shanghai Maglev Train in China, which connects Pudong International Airport to the city's outskirts. It reaches speeds of up to 430 km/h, 268 km, making it one of the fastest commercial trains in the world. This achievement showcases not only the marvel of engineering, but also the passion and perseverance of scientists who turned the dream of floating trains into reality. But why use maglev trains? The absence of friction means faster speeds and lower maintenance costs. These trains are also quieter and more environmentally friendly since they use electricity, not fossil fuels. It's a glimpse of what the future of travel could look like. So, next time you hear about maglev trains, you'll know they're not just fast. They're a remarkable combination of science and innovation. Who would have thought that the properties of magnetism, discovered hundreds of years ago, would lead to such futuristic travel? Maglev trains remind us that the wonders of science can make dreams of hover trains come true, pushing the boundaries of what's possible.